In this second ecology screencast, let's switch from population dynamics to attributes of communities. Community diversity is a measure of how many different species are present in a community and the relative abundances of these species. Let's compare two communities with different diversities. Assume both communities have 1,000 individuals with very even numbers among the species. Community 1 has 5 species, Community 2 has only 3 species, therefore Community 1 will have the greater diversity. Now let's compare two more communities. Community 1 again has 1,000 individuals evenly distributed among the 5 species. Community 3 also has 1,000 individuals and the same 5 species. However, in Community 3, it is dominated by Species A, which has 980 individuals, and very few individuals of Species B, C, D, and E. These two communities are very different. Community 1 again has the greater diversity. Imagine taking a walk through each community. What would you see? Many different factors influence community diversity. One factor is disturbance. Disturbance is a short-term event which kills or displaces organisms. The intermediate disturbance hypothesis states that the highest levels of diversity should be found on areas with moderate levels of disturbance. One application of the intermediate disturbance hypothesis is the management of wildlife refuges. A common goal on many is to create a home for as many different species as possible. In this graph, the intensity of the disturbance, measured in terms of frequency or size of the disturbance, is plotted on the x-axis, and population, also called community diversity, is shown on the y-axis. The highest diversity is seen with moderate levels of disturbance. Remember R and K selected species? R selected species are most abundant in areas with high disturbance levels. K selected species do best at low disturbance intensities. Moderate levels of disturbance will have a mix of both R and K selected species and therefore higher diversity. Habitat is the place where an organism lives. Various attributes of habitat influence diversity. The equilibrium hypothesis of island biogeography incorporates some of these attributes. MacArthur and Wilson initially developed the hypothesis to predict the diversity on islands, but it is now useful when investigating factors influencing diversity on any area of good habitat that's surrounded by unsuitable habitat. Ultimately, the hypothesis uses factors influencing how quickly species find an area, and then how likely it is they're going to survive once they get there. One important factor is how far the individuals have to travel to get to the island of good habitat. All other factors being equal, Island A would be expected to have a higher diversity since organisms are more likely to survive the trip to A as compared to B. Another factor determining diversity is the size of the target. Assuming individuals are leaving the mainland, not knowing where they're headed, a larger island is more likely to be found by the searching individuals, and as a result, should have a higher diversity than the smaller one. In general, larger islands should be expected to have more resources than smaller islands. Therefore, survival rates, and as a result, diversity, should be greater on larger islands than smaller ones. In addition to larger size resulting in more of a specific resource, it's also likely that there will be a greater variety of different resources on the larger islands. This will make possible the survival of a greater variety of species. While the equilibrium hypothesis of island biogeography was devised with ocean islands in mind, the hypothesis has proven useful when designing and locating refuges which are surrounded by agricultural or urban landscapes. This is the end of the second ecology screencast.